Welcome, Algebra 2. This is section 2.1, Relations and Functions. The essential question is, what is the difference between a relation and a function? Let's begin. So, a relation is a set of pairs of inputs and outputs. So, four different ways to represent relations are ordered pairs, where the left one's the input and the right one's the output. And this is, you've also seen this as xy, so -3 is the x, 4 is the y. These are inputs and outputs. Another way is this mapping diagram. We don't really use it that much. But we have a set of inputs on the left, outputs on the right, and arrows that point to the outputs. So this -3 on the input goes to the output 4. So the arrows kind of show the pairs. Another way is the table, and you'll see this a lot. And we've done this before, where we have an input on the left, and then and then we have the output that corresponds to the input on the right. Another way to graph that, usually we take the table of values and actually graph it afterwards. So this point right here, this is -3, 4. And that corresponds to this input-output table here, this arrow right here, and this first order paired right here. These are all the same set of pairs, but it's just four different ways of representing them. Now, two other things, domain and range. Domain is all your inputs, or the x coordinates, and range is the outputs, or the y coordinates. What does that mean? Well, let's say I have this set of ordered pairs here, these four. What's the domain of those four? Well, it's all the x values here. So it's going to be 5, -2, it's going to be 0, and it's going to be -1/2. Those are the domain, that's the x values. The range of the y values, and that's going to be 2, 1, 0, and -100. Now this graph right here, we could do it the same way. These are each points. This is -3, 4. And this point is going to be at 3, 3. And we have 2 points. The first one's at, oops, this wasn't 3, 3. This was 4, 3. 4, 3. This one's going to be at 3, -1. And this one on the right is going to be at 4, -1. So if I have those 4 points, my domain is my x values, which is -3, 4, 3, and 4 is done again. But we only need to list it once. So -3, 4, and 3. The range, the y values, well, the highest one here is 4, and then we have 3, and then we have 2, -1. So just list -1 twice. So that's the domain and range. A function. So a function is a special case of that domain and range, where each domain, x value, has only one y value. So each x only has one y. So here's two examples. This first one, this is a function, because for every x value, there's only one y value. If x is -3, y has to be -2. If x is 0, y has to be 7. If x is 4, y has to be 1. The one on the right is not a function, and it's because of two pairs. These two right here. This one right here, and this one right here. The top one says if x is 4, y is -1, but the bottom one says if x is 4, y is 1. These are the two of the same x values right here, but they have different y values. So those things, these two ordered pairs, make this not a function. Now, you see these 6's, if x is 8 and y is 6, if x is 6, y is 6, this is okay. This stuff right here is okay, because we can have different x's with the same y values, we just can't have the converse of that. We can't have the same x with different y values. Alright. Another thing you can do with functions to test is a vertical line test. And you've done this before, probably in Algebra 1. So what you do for vertical line tests is if a vertical line passes through more than one point, then the relation is not a function. So you just draw a vertical line. I'm going to demonstrate this right here. So I can draw a vertical line straight up and down on this first one, and this is definitely a function, because it always only crosses the function at one point on that line, no matter where you put a straight line. Now the next one is not a function, because when I do straight up and down lines, like just in that case, it crosses at 2 points, right there and right there. And it keeps happening. All it has to do is happen once for this not to be a function. I don't need to draw extra lines. Next one is a function, because it's all about drawing straight up and down lines. And all of these, even though the graph goes up and down a lot, it's all just crossing once. And the last one is a function as well. This is supposed to be a parabola, and it's always just crossing at 1 point. Nothing's never going to cross at 2. So let's work on the next one. Function notation. This is new. You probably didn't see this in Algebra 1. This is the way we write a function. So you're used to writing y equals 3x plus 2 to write the equation for a line, right? Well, function notation changes this a little bit. We say f of x equals 3x plus 2. You read that as f of x. This is the same function here. So this is not f times x. This is f of x. This is saying y and saying f of x. These are saying the same thing. This is function notation. The f of x is our dependent variable, or output, and the x is the independent variable, our input. So instead of saying x is input, y is the output, x is the input, f of x is the output. Right? So one thing we can do with this is we can evaluate for different inputs. So if we have the equation f of x equals 3x plus 2, we can evaluate for f of 1. What does this mean? When I say f of 1, it means plug 1 in for x. So you're substituting 1 in for x here. So we got 3, instead of 3 times x, it's 3 times 1 plus 2, which is going to be 3 plus 2, which is going to be 5. Alright, let's try these examples. Pause the video. 2, 1. Alright, for the function, what is the output when the inputs are 3, 0, and 1/4? So we'll do this in all three cases. So the first one for negative 3 is f of negative 3 equals negative 2 times negative 3 plus 5. So negative 2 times negative 3 plus 5 is going to be 6 plus 5, which is going to be 11. So that's my first one. For the next one, that's going to be f of 0. So you're plugging in 0 for x. So you get negative 2 times 0 plus 5. Well, negative 2 times 0 goes away, so I'm just left with 5, and that's my answer. For that last one, we have f of 1/4. So I'm going to write a fraction like this. So we plug that in, negative 2 times 1/4 plus 5. Well, negative 2 times 1/4, that's going to simplify to negative 2 or fourths, or negative 1/2 plus 5. And so I want to convert that 5. I want to write that as a fraction. That 5 can be written as 10 fifths or 10 halves. So I got negative 1/2 plus 10 halves, multiplying that by 2 over 2. And we can combine the numerators, and that's going to be negative 1 plus 10 is 9 halves. So my answer is 9 halves. You can leave it like that. Last one, pause the video. Alright, what is domain and range? Is it a function? So the domain, I'm going to abbreviate it with just a D. It's all the x values here, so it's going to be 3, 4, 0, 4 is repeated, and 3 is repeated, so I don't need to write them again. So the domain is these three numbers, 3, 4, and 0. The range is going to be the y values. So we got negative 2, 4, negative 2 again, doesn't matter, 1, and positive 2. So these are my y values, my range. Is this a function? Well, for every x, we can only have one y value. But it's not a function because we have these two ordered pairs, which mess it up. So for the same x's, 4, we have different y values, or outputs, 4 and 1. And what also messes it up is these two ordered pairs, because we have the same x value but different y values. So is this a function? No. Now the bottom one. So the domain in this one is going to be 1, 2, 3, 4, and 0. Now the range, the outputs, is going to be 1, 0, 1's repeated, so 3, and 2. Alright, there's domain and range. Now, is it a function? Well, looking at this function, every x value is different. So every x value, we're not going to be having two different outputs for the same x value since we don't have any repeating x values. This is, yes, definitely a function. Alright, that's it.